Here are your notes for section 7.3. Examples. Number 18 gives you an equation in exponential form and asks you to change it into logarithmic form. So if you want to write an equation in logarithmic form, we're going to make an L for logarithm. So you do log first, because we're changing it into logarithm. So you make your L, come down to the 6, that means that's your little base, your base is 6, across the bottom of the L to 216. So it's log base 6 of 216, and then up and around is equal to x. And remember that, so this kind of looks like an L, it just helps you remember the pattern and what order to put these in. Log, this is a little base number, that bottom number is written smaller and lower, of 216 is equal to x. And that's all they wanted you to do, just rewrite it, write it in logarithm form. 22 is asking you to go the other way. This one gives you an equation in logarithm form and asks you to change it into exponential form. So if you want to write it in exponential form, that means it's going to have an exponent. It will no longer have a log, so you're not going to have the log in front anymore. And we make the e, so we're going to start with 2. We need an exponent, so you go around, you make your e. 2 to the 6th power equals x. And this is going to be really helpful when we try to start evaluating logs. Remember, you're always thinking to yourself when you see a log, 2 to what power equals x? Or if it's asking you to rewrite it like this one, 2 to the 6th power equals x. Logarithm means power. The last one that I'm going to do for this lesson is number 26. Use mental math to evaluate that logarithm. Notice there's not a base written on this one, so anytime they don't have a base written, that automatically makes it base 10. That's the most common logarithm. So if there's not a base written there for you, the base is 10. And if we go back to the last example that we did, number 23, when you're evaluating a log, it means the base to what power? You're trying to find the power. So on number 26, 10 is the base. To what power? I'm going to put a question mark. To what power would equal 0.001? And this one's a little more difficult to do with mental math than some of them would be. And I'm not going to do it. I'm going to show you what I would kind of do in my head. It's not necessarily. So if I started with, I'm going to start counting. So 10 to the 1st power would equal 10. So if I work my way backwards, because I want a decimal, 10 to the 0 power, well, anything to the 0 power is 1. So I've gone back a decimal spot now. Go back again, 10 to the negative 1. I'm going to keep moving the decimal back one. As the exponents get smaller, the decimal moves back one spot each time. So 10 to the negative 1 equals 0.1. 10 to the negative 2 would equal 0.01. 10 to the negative 3 would equal 0.001. So what if it's 1? That one's a little bit tough to do with mental math. Let's see if we can just do one. What if we have log base 2 16? So we do 2, log means power. 2 to what power is 16? So you just have to start counting by 2's to yourself. 2 squared is 4, multiplied by 2 again, so 2 to the 3rd is 8, multiplied by 2 again is 16. So 2 to the 4th equals 16. That means that when you evaluate this, 2 to what power equals 16? Well, 2 to the 4th equals 16. So that logarithm equals 4.